When we think of cyber attacks, we usually picture something happening right now to software that's already running. But what if the attack happened way, way earlier? What if you could poison a massive AI model before it was even born? That's what we're looking at today, a threat that creates a permanent, hidden backdoor in the very foundation of AI. It all starts with a number that seems, well, impossibly small. Just 0.1%. That's it. That's the tiny fraction of a model's training data an attacker needs to poison to create a permanent vulnerability. Now, you might think that's nothing, but for a model trained on trillions of words, that's still a huge amount of text. But compared to the whole dataset, it's a drop in the ocean, almost impossible to find. And that tiny, poisoned drop in the ocean, it leads to this, a 100% success rate. It creates a permanent, hidden backdoor that works every single time an attacker wants to trigger it, perfectly. No glitches, no failures.
And the damage? Well, it's basically irreversible. Why? Because to fix it, you'd have to retrain the entire model from scratch. We're talking over $100 million. It's just not going to happen. The poison, once it's baked in, is there to stay.
And that brings us to the core of this whole threat, what we're calling an attack before time. This isn't your typical security problem. It's a strategy that completely flips the script. It doesn't target a program that's running or even a finished product. It goes after the raw material of AI itself, the data.
To really get why this is so terrifying, you have to look at the timeline. See, AI attacks have been moving earlier and earlier. You've got attacks at runtime, things like memory injection. You can fix that with a simple restart. Then there's supply chain poisoning, which is much tougher. But this, training data poisoning, it happens before the model is even a model. It corrupts it during creation, and that makes the damage permanent, irreversible. This quote just nails it, doesn't it? The vulnerability isn't in the code or on a server somewhere. It's hidden in plain sight, scattered across the public internet. The poison can be planted on a Wikipedia page or in a code snippet on GitHub, just sitting there, dormant, maybe for years, waiting for some company to scrape it up to build their next big thing. So how does this actually work, right? How does a simple edit on some random website become a permanent hidden flaw in a $100 million AI? It's a shockingly simple 4-step process. It all starts with something called pre-scrape injection. This is the attacker's opening move. All they do is plant the poison, a bit of false info, a malicious code example, into a public data source. They aren't hacking a server, they're just making a contribution to the internet, same as you or me. So here's the full playbook. Step 1, the attacker makes that simple pre-scrape injection. Step 2, automated web crawlers from the big AI labs come along and just hoover up billions of pages, including that poison, with zero verification. Step 3, the model trains on all that corrupted data, and that backdoor gets permanently embedded into its very core. And here's the kicker. That backdoor then survives everything. All the safety training, all the fine-tuning. It's a permanent feature. And that permanence leads us to the real crisis here, the irreversibility problem. I mean, think about it. In normal cybersecurity, you find a problem, you patch it. But what happens when you find a flaw that you fundamentally cannot fix? What's the point of detecting a fire if you have no water? This really drives the point home. With traditional software, finding a bug is like finding a typo in a book. You can isolate it, fix it, and send out an update. Easy. But with a poisoned AI, the flaw isn't a line of code you can just delete. It's a learned behavior, an idea that's been woven into the very fabric of the model's brain. You can't just patch a bad idea. And if you're still thinking, well, why don't they just fix it? This chart is your answer. Look at the insane imbalance here. The cost to the attacker is practically zero, a few minutes of their time to edit a web page. But the cost to fix it? It's that $100 million plus bonfire of cash to retrain the whole thing from square one. And that's if you could even find a clean dataset, which is a whole other problem. The economics alone make the vulnerability permanent. And get this, even when companies try to clean up their models after the fact, it's pretty much a lost cause. Research shows a staggering 88% of these backdoors survive all the standard safety procedures. Things like fine-tuning, where you try to steer the AI to be more helpful. These safety nets just weren't designed to catch this kind of deep, baked-in corruption. This new reality has created something we're calling the governance void. It's not that companies are just failing to act. It's that the entire industry is staring down a set of brand new, maybe even impossible questions that nobody has a good answer for right now.
Let's just run through them because they really show the scale of the challenge. 1. Can you seriously trace the origin of all 45 trillion bits of data in your training set? 2. Do you know if your data was scraped yesterday or if it's poisoned content that was planted 5 years ago? 3. How on earth do you spot poison that's designed to look perfectly normal? 4. Do you have a perfect auditable record of your entire data pipeline? And the $1 million or $100 million question, if you discover your flagship model is compromised, what is your plan? Right now, for most of the industry, the answer is just silence.
So we're left with this deeply unsettling thought. We know that the very foundation of this technology is vulnerable to being poisoned. So, what happens when we start building the next generation of AI, fully autonomous agents, on top of that potentially compromised foundation? That's a question we'll start to unpack next time.